All right, hi, I'm Carl. Me and Ryan will be going over 1 and 2 sample significance tests for categorical data. Like also, I'll go over significance tests for 1 sample categorical data. So for the state part of the significance test, first thing you want to do is state your null and alternative hypothesis. And the next thing you want to do is you want to state the givens. The givens are sample size and predicted proportion. And the most important part, and the part where people mess up on, is defining your parameter. You want to always state that it's the true proportion or the population proportion, and then give context afterwards. So for the plan part of the significance test, I always like to state what kind of test I'm doing, and it's not always the name of the test in your calculator, so you shouldn't write down whatever the calculator says. I wrote for 1 sample categorical data, 1 sample z-test for a proportion. It's just 1 proportion because it's 1 sample. And then you want to check your conditions, and your conditions are large counts, 10%, and random. So for large counts, always use the predicted proportion and never the actual successes in the problem. You want to do it for what they think the successes are going to be and what they think the failures are going to be. So you want to calculate both successes and failures. For 10%, you want to state the sample and say how it's less than 10% of the population while also talking about the population. And for random, you want to state that it's a random sample and you want to give context why. So for this problem, it doesn't actually tell you it's a random sample, so you have to make a reasonable assumption that it is a random sample based on the context of the problem. So for the do section of the significance test, I like to do it on a calculator usually because it's a lot harder to do by hand, or a lot slower actually. So you go to menu 6, 7, and then you look for the test that you want to do. In this case, it's a 1 proportion z-test. It's pretty easy to put everything in since you already have everything written out for you. So you put everything in, you press OK, and then it spits out all these values, and you want to put all these values down on your paper. You put everything that you put into the calculator and whatever the calculator spits out. Also, you want to write the formula of the test statistic, because if you do calculate it wrong, you'll at least get a P if you have the formula already written down. Finally, the last part of the significance test, the conclude section. So either the p-value is larger than the significance value, or the p-value is smaller than the significance value. So if it's larger, then you can't reject the null. And if it's smaller, then you do reject the null. And then you say you either have convincing evidence or you don't have convincing evidence of the alternative hypothesis. So if the p-value is larger than the significance value, in this case, we can't reject the null, and we don't have convincing evidence to support the hypothesis.
All right, guys, so now we're going to do significance tests for categorical data with 2 samples, or a significance test about a difference in proportions. So first, I'm going to be doing a practice problem on page 631, 10.1, and number 14 talks about steroids in high school, specifically in first state the parameters. I'm going to use this rubric: the true proportion of Illinois seniors that are using anabolic steroids. And I'm going to do the same for freshmen. So once I have my parameters, I'm going to state what I know. So my p-hat1 is the total amount of seniors who use steroids divided by the total amount of seniors in our sample, which then we are going to have a pooled statistic, and that will come later when we actually conduct the significance test. Next is our null and alternative hypothesis, and our null is always going to be equal to 0, but our alternative hypothesis, we need to see if it's a 1 or 2-tailed significance test, and it says, do the data give convincing evidence of a difference in the proportion? So difference implies that it is just not equal, so we can circle that. Next is plan. So we want to first state what kind of test we're using. State 2 sample z-test for difference in proportions, not 2 prop z-test, because that's what the calculator said. I did that on the test. First, I want to check the normal conditions. So n1, p1, and this p is p-hat. So we're going to use p-hat, and so that's, instead of simplifying it and taking the statistic that we calculated, we can just say 24 over 1,366 and just go that multiplied by n1, so it just simplifies to 24. You do that for 1, and then you do it for n2, p2, n2, 1 minus p2, and they're all greater than or equals to 10, so the normality condition is satisfied. 2 independent, remember independent, random samples of Illinois high school freshmen and seniors, and just over 1,000 of seniors and freshmen in high school in Illinois is less than 10% of the total population. Use our calculator for the do. So we're going to use menu, statistics, stats test, which is 7, and then a 2 prop z test, because we're looking at 2 proportions. So we're counting successes as the amount of people that took steroids in our sample. So in seniors, we have 24 successes, 1,366 total seniors. So we're going to put in 24 over 1,366. The other one is 34 over 1,679. And this is a 2-tailed significance test, so P1 is not equal to P2. We get a p-value of 0.590, and a z statistic of negative 0.538, and a pooled statistic which goes into our state of 0.0190. All right, p-value is 0.590, which is greater than our significance level of 0.05. Remember to state what your p-value is and your significance level, and say if it's greater or less than. We fail to reject our null hypothesis. You can just abbreviate it as HO. And then you want to say if there's convincing or not convincing evidence to conclude of hypothesis. So we say that there is not sufficient evidence to conclude that the anabolic steroid use is different between seniors and freshmen in Illinois.